Hello everyone. So we are back with the fifth lesson on this recording series for these hard questions on the SAT suite. So here we have some number like 70n raised to the fifth power times 70n again raised to some other power equal to 70n to the power something else. So since it's 70n everywhere, we can just assume that 70n is some k, right? You don't need to split that. And then we have k raised to 1/5, k raised to 1/6 squared equals k raised to 30x. Simplifying on the left side, we have k 1/5 times k 1/3 is k to the 30x. That gives you k, the powers gets added. So that becomes 8 over 15. Now comparing the exponents, that gives us x to be 8 over 15 times 30. So we'll cancel the 2. So we have 4 over 225. All right, let's go to the next question. All right. So here this one says fx is a product of three factors here given, right? So what we now do is we have a new function gx, which is obtained by translating the graph of fx 4 units up. So when we have 4 units up, we can definitely then say that gx is fx plus 4. That's it. So g0, that's what they want, should be f0 plus 4. So you don't really need to find out what is gx as such, okay? We just need to figure out what is f0. So from the given expression of function fx, f0 would be 0 minus 6, 0 minus 2, and 0 plus 6. So it's negative 6 times negative 2. So that becomes 12 times 6, 72. So then this becomes 72 plus 4. So that's 76. Okay, next, let's move on to the next question. In the expression above, b and c are positive integers if the expression is equivalent to x plus b. So here they are saying that x squared minus c over x minus b equals x plus b. X is not equal to b, so that the denominator does not become 0. So we just cross multiply, right? Okay. X squared minus c equals x minus b times x plus b, which then becomes x squared minus b squared. So x squared cancels out from both sides. So we end up with c equal to b squared. So c is a square of some positive integer. So that means only a perfect square is possible. The only perfect square here is 4. The others are not perfect squares. So the answer is option A. Okay, let's go on to the next one. So we have an equation of this side. So to solve this, we'll just square out both sides. So we get x minus 2 squared equals 3x plus 34. That's our first step. So let's simplify it. X squared minus 4x plus 4 equals 3x plus 34. That is x squared minus 7x minus 30 is 0. So that would be 10 and negative 3, right? Negative 10 and 3. So x minus 10 times x plus 3 is 0. Okay. So that will give us x equals 10 or negative 3. Now we just need to ensure that before we squared, since the original equation has the root form, so before we squared, the expression inside the roots don't become negative. Okay, because then that's not a valid solution. So on the left hand side, it's inside the root, you have something squared. Okay, so that's not going to make any difference. Okay, because if even if let's say x minus 2 came out to be a negative number, okay, so you anyway square it, right? So it will become positive. So then there is this root of that. So there is no issue. The only issue you need to check the right hand side, 3x minus 34. Now, if x is 3x plus 34, so if x is 10, then this is 30 plus 34, 64, which is fine. If x is negative 3, then this is minus 9 plus 34, which is still positive, so that's also fine. So there is no problem. Both are fine. They're saying the smallest solution, so that's negative 3. Let's go on to the next one. So you have a quadratic function that models a projectile's height in meters above the ground in terms of the time. Okay. The model estimates that the projectile was launched from an initial height of 7 meters. So let's say if this was the 7 meters high building from where it was launched, and the projectile kind of follows this trajectory, let's say, okay? Like just visualizing it, right? Like the flow of distance over time, okay? Kind of relationship, which is going to be a quadratic relation. So now it says that it reaches a maximum height of 51.1. So this is 51.1 meters, 3 seconds after the launch. So this is time, this axis is time, and this axis we are looking at is height, okay? Please don't confuse this with the actual flow of the projectile, okay? Actual movement of the projectile. I mean, this is not the trajectory of the ball I have drawn, okay? So I'm basically drawing is the function of the height versus time for that projectile or the ball, whatever you have thrown, okay? So it's saying that after 3 seconds, it's at 51.1 meters. Okay, this is at 0 seconds because you threw it at from a height of 7 meters, right? How many seconds after the launch will it return to a height of 7 meters? So they're saying basically, when will it again be a 7 meter height? So the easiest way of doing this is using the concept of symmetry rather than getting into what the equation of this quadratic would be. Okay. So we know that this is a quadratic function and it's going to be symmetric about the line of symmetry, about the peak value, right? This is the line of symmetry passing through the vertex. So this distance and this distance must be the same. This is, we know 3 seconds, so this must be 3 seconds. So this is 6. So at 6 seconds, it will again be at a height of 7 meters. So that's the answer. Right? Okay, let's go on to the next question. So we have something like this, and it says that the product of the solutions of this is KAB. K is a constant. What's K? All right. So if you have a quadratic equation, so in any quadratic equation, ax squared plus bx plus c, and if the solutions or the roots are R1 and R2 are your roots, then product of the roots is the constant c over constant a, and sum of the roots is negative b over a, okay? This is a standard relation which can be easily obtained by factorizing and rewriting this equation into form of the roots, okay? I discussed this in my lessons. So in this case, what I simply have been asked to do is what is the product of the solution? So that is going to be the constant term, which is the AB in this case. The product is AB over the x squared coefficient. And this they are saying is KAB. So AB just cancels out. You have K equals 1 over 57. That's it. Okay, that is all we have in this. Alternatively, if you are not aware of this formula or not aware of this relation, we can still do something pretty neat. We can say that, okay, this is a quadratic. A and B are uh, so the solutions, let's say, are R1 and R2. So we can write this equation to be, because 57 is here, take out 57, x minus R1, x minus R2. So these two are equivalent solutions, okay? Equivalent equations. So what's the constant term here? AB. What's the constant term here? So we have AB equals 57 times R1 times R2. Negative R1 times negative R2 actually, but negatives and negatives multiply and give you positives. So R1 times R2 is AB over 57. So we have got the same thing. And this is K times AB. So from here we get the same relation that K is 1 over 57. All right, let's go on to the next question. So here they are saying that 3x squared minus 18x minus 15 is 0, and they're asking you the value of something. Now it is up to you to, if you can notice this, that 3x squared minus 18x is just thrice of this. So we can just take out the 3 common, write x squared minus 6x, and write that it's equal to 15. So 15 goes that side, right? Just divide by 3, you have the answer. So it's very important to keep track of what the question is asking. They're not asking you the x. So don't start solving for x. Okay. There's no point of solving for x. Get two roots. Then calculate x squared minus 6x maybe for both the roots and then take a call. What is the value? That's like completely unnecessary wastage of time, right? You have to observe these things. Then it's just like a 5 second question. All right. Let's take another one. The function f is defined by fx is this. And in the xy plane, fx minus 15 has this. So fx minus 15 here would be, since fx we know is negative a to the power x plus b, y would be negative a to the power x plus b minus 15. At x is 0 here, y is negative 99 over 7. So that gets us negative 99 over 7 equals, plugging in x as 0, minus a raised to the power 0 is minus 1 plus b minus 15. So that gives us b to be 16 minus 99 by 7. So that's 3 over 7. 16 times 7 is 102. 112, sorry, my bad. 13 over 7. Okay. 16 times 7 is 112. 112 minus 99 is 13. 13 over 7 is b. They have said a times b is 65 over 7. So obviously the value of a is like 5, because 13 times 7 multiplied by 5 will give you 65 over 7. So the answer is 5. All right, let's stop here. For now, we'll come back with the 6th edition of this series. Thank you for watching.